They are the last of the problems from the April break, and they're from 2012 on the second haiku I gave you. They're both no calculator. So this was number 4. I thought number 4 was pretty easy. The key to the question is that you're given an equation and they give you a closed interval. And if you know that this is the graph of a semicircle, that's a huge advantage to this problem. First question is very mechanical. They want you to take the derivative. And you take the derivative using the chain rule, which I'm sure you're hopefully okay with. And the key is here is simplify. Okay, so we simplify the derivative and we should get what's in the box. And again, that's the mechanical part that's going to get you going in these questions. Question B, they want you to find the equation of the tangent line at x equals -3. So you put -3 into the original and you get -3 comma 4, and then you put -3 into the derivative. Negative and -3 over the square root of 16 is 3/4. So here's the line that might help you out, but here's your equation. And keep the answer in point slope form and move to the next problem. So that's pretty straightforward. Question C, you don't need to know the graph, but the graph certainly would be helpful. It's the semicircle that goes to -3 comma 4, and if I put -3 into x plus 7, -3 plus 7 is 4, and it goes to 5 comma 12. So it's essentially the semicircle to the line. But the question asks for continuity. You can't just say the graph meets at -3, 4. You have to show continuity by explaining that the function values are the same from both sides of the piecewise function, and the limit from the left is the same as the limit from the right. So the key is you got to show one-sided limits to show continuity here. The limit as x approaches -3 from the left of the semicircle goes to 4, and the limit as x approaches -3 from the right of x plus 7 also goes to 4. So basically, the limit as x approaches -3 is 4, and g of -3 is 4, therefore it's continuous. So the APs would be looking for that one-sided limit concept, not just saying that it meets at the graph. Question D is a good problem. It's doable. The question just basically says to evaluate an integral, and it's a UDU problem, and it's a U substitution problem. So this is a nice review. Okay, so establish inside the radical my U, my du. Okay, pretty self-explanatory there. And then I also put the U of the lower limit and the U of the upper limit. So this is a good review question here. Remember, you switch the limits, and if you notice, the substitution here is the key, because the lower limit is now the bigger number than the upper limit. So I reverse the limits of integration, and then the sign changes to positive. I evaluate u to the 1/2, which is 2/3 u to the 3/2. And then from here, remember, you just substitute the upper limit in for u. You don't replace the u, okay? Again, if you want to replace the u and you don't do u substitution, the APs do allow that, but I would suggest doing what I'm suggesting here. Now substitute, and 25 to the 3/2 is 125. Recall that 25 to the 3/2 is 5 squared to the 3/2. So that would be something that the APs would expect you to know. So if you need to review that real quick. And your answer should be 125 over 3. That's a good problem to review, with U substitution, equivalent integrals, things like that. The second problem is a fantastic AP question, and I remember it 8 years ago, and I thought it was just something that was really good. If I were to predict an AP question this year, being that it's going to be a different test, I would really highlight differential equations and slope fields and the like, separation of variables. This is a great problem. So they give you dB dt, and this was kind of like your take-home quiz, like the first question. I substitute both 40 and 70 into the rate of change, and the two answers I get are 12 and 6. I originally had 60, but I crossed it off. It's 12 and 6. 12 is bigger, so the 12 represents that I'm gaining weight at a faster rate at when I'm 40 grams. When the bird is 40 grams, it's gaining weight at a faster rate. That's what this 12 means, okay? And that really answers question A. Question B, truthfully, a lot of you kind of got wrong on the review quiz that was during a couple weeks ago or before the April break. But the second derivative, you take the derivative of this, okay, which would be 1/5 times negative dB dt. And then you replace this whole thing with dB dt. And that's what I did here, okay? And then you get the second derivative here. So you will get credit for finding the second derivative. You could distribute that, the APs would accept it, or just leave it like this. The key to this problem is that if you look at the graph, whatever weight I put in between 20 and 100, not including 100, which I made a mistake on, it's really just less than. Because if it is 100, the experiment's over. Because 100 minus 100 is 0. It's always going to be negative. Okay, so the second derivative is always negative between 20 and 100. Therefore, the original graph has to be concave down. And if you look at the graph in the problem, okay, if you look at the problem, kind of looks like this. There are some points where it's not concave down, clearly, and that would mean that this graph is not acceptable. And that's what they're trying to tell you in this problem. Again, that's just one of those quirky questions that come up from time to time. Question C is a textbook separation of the variables problem. So, you know, again, I would totally review this ongoing here. So, you know, this is your original differential equation, and then you cross multiply, you get the b's on one side and then the 1/5 dt on the other, and then I integrate both sides. So, you know, again, you might want to slow this down and do this in parts, but the key is to, you know, integrate both sides. Now, the integral of 1/5 dt is easy. It's 1/5 t plus c. But integrating where the u is 100 minus b, the du is minus db, so minus du equals db, and then replace that, and you're going to get a natural log. So again, work to get this box right here, okay? And I think that's the key. Now from here, there's a couple of ways to do the problem, okay? I've taught that you solve for c right away, okay? And if you do that, you get the natural log of 80. You could take the negative and divide the negative through, and remember it's still a plus c, and then take the e of both sides, and that will get you to this problem. And then if you want to, you can use the initial condition here, which I recommend also, because if you have 100 minus b equals c e to the negative 1/5 t, with the initial condition, you get 80 equals c e to the 0, so c is 80 because e to the 0 is 1, right? So that might be the best way to do it, and then solve for c, which I did, and then you basically from there solve for b. So, you know, bring the 100 to the other side and then divide the negative. And this will give you the answer they're looking for. This is a great problem. If you solve for c initially and then you put it in here, that might be a little tricky, but again, if e to the negative ln of 80, you'll eventually work it out to being negative 80. So I would just practice it, to be honest with you. That would be my suggestion for this problem. And that's really the work for these two questions. So I've done every AP problem, so maybe we can talk about, maybe you look at it and see if you have any questions. Thank you.